Hello everyone and welcome. Today's topic is about data pre-processing, which is a crucial part in all data-driven processes and pipelines. It's the act of preparing a data set and transforming the raw data to cleaned and suitable for modeling or analysis. Raw data is all data gathered from any sources that could be different types and sizes, unordered, unstructured, contains multiple formats, and doesn't follow a certain standards. The main steps: gathering the raw data, cleaning, transforming, and then we will be using the cleaned data. And to be able to achieve this process, we will be using the Pandas library that could be downloaded using pip. First, let's import Pandas. Then let's import our dataset. I will store the path in this variable, and then dataset equals pd.readcsv, and let's provide this path. Let's print the length of our dataset. You can see that we have 1370 records. The info of this dataset, we could see here that it's of class Pandas data frame. It has 103,070 entries, 18 columns. First column is a name till processor name. We have one column of type float, two of type int, and the rest is object type or string type. We could also print the columns in a list format, as you could see here. First, let's start with transforming all the names of these columns to lowercase. Let's use dataset.columns equal to dataset.columns.str.lower, and this lower is a method of the str library or the str property. All of these names are now in lowercase. We could also print some records of this dataset using the head method, dataset.head. And here we could provide the number of records that we want. If we say 1, we will have only one record. As you can see here, the first phone is Samsung Galaxy, rating 4.67, 68 spec score, etc. If we provide another number, for example 5, and here we will have 5 records, as you can see, 0 till 4. The method of choosing some columns from this dataset related to the study case that we are in. So let's divide our columns into two types: the categorical columns and the numerical columns. And also, let's not forget our target column. Alright, so for the categorical columns, we took company, processor, and processor name. For the numerical columns, we took RAM, battery, display, Android version, inbuilt memory, fast charging, and camera. And for our target column, we took the price. First, let's remove all of the columns that are not included in this tree. And to do that, let's use a for loop. So, for column in dataset.columns, if this column is not in our categorical plus numerical plus the target, simply dataset.drop this column at axis 1, the columns axis, in place equals true. And this means that don't assign it to a variable, just do it directly in this data frame type. We have our numerical and categorical and our target price column only. There is also a certain method to remove duplicates from our dataset, which is .drop duplicates. And let's use the in place equals true. There's also a method to remove the non-values or the missing values, which is the drop now. We provide the axis, so we want to remove axis 0, the rows. The method to remove is all, so we will remove a certain record if all of our data is none or missing. And also we provide in place equals true. We could also print the percentage of the missing values using a for loop. So for column in dataset.columns, here let's print our dataset at specific column dot is now will return true if a record is missing, and sum, so we will sum all these records. Then let's multiply it by 100 and let's divide by the length of our dataset. Now let's execute this line. We have Android version with 32% of missing values. We have 1 for inbuilt memory, fast charging is 6, 2 for processor, and the rest is 0. This means that these columns does not have a non-values or missing values. In some cases, we could remove this Android version because it has a lot or a big percentage of missing values. But in our case, let's leave it right here. To make this video short, I will pre-process the categorical columns here right now. And for the next video, the numerical ones. First, let's start with the company column. So let's print dataset company unique values. We could see that we have nothing value. We have Oppo with multiple format, also Intel. So let's change all of these values to lowercase. Dataset company equals to dataset company str dot lower. This right here will transform all of these values into lowercase values. Right now we have only one Intel, one Oppo, etc. Let's remove this nothing value. We will use the replace method. So dataset dot replace, and we will replace this nothing to a NaN value. And to use the NaN, I will first import NumPy. Import NumPy, and let's have here np.NaN. I will say regex equals false because here we are not using regex format, and in place equals true. Our nothing value, sorry, I have it uppercase here. Let's print again. So we could see that our nothing value changed into a NaN value. For the second column, which is the processor column, so processor, let's print unique values. You could see here we have octa core, quad, 9 cores. First, we could see that we have some spaces here. Let's remove them using the str strip method. .astr.strip. Let me print again, and we could see that these spaces are removed right now. Then let's use a regex to remove all of the digits. Dataset at processor .str the contains method, and here let's write a regex 1 or plus digits or numbers, and then we have a point, as you could see here, dot, and then this dot is optional. For example, here we don't have a dot, and then also we have the star, and this means that we could have 0 or plus digits. Let's use regex equals to true and now equals to false, and this to skip the NaN values. Let's have it as a mask, and now to use this mask we will use the locate or lock method. So we have dataset.lock. Inside this lock, we first provide our mask and then the column that we want equals to numpy.NaN. All of the records that have digits, optional dot, and then other digits will be all removed. As we could see here, all of the ones that have digits are removed and treated as none. Then let's use the replace method to change these names to one format. For example, here we have octa-core processor and octa-core, deca-core processor and deca-core. This could be only deca-core. Let's have here dictionary format. First, we have this will be this one. After this dictionary, regex is false, and in place equals true. And as we could see, we have octa-core, quad-core, 9-core, and deca-core. And also the rest of the values are all changed to be none. For our last categorical column, we have the processor name. It might sound like very hard process to check for all of these names, but to simplify the process, we will only remove the numbers and the spaces. First things first, let's remove trailing spaces. Next, we will remove also these numbers. We will use regex. And here we have our regex. We could see that we have a mix of numbers and strings or characters. We could see that we have a mix of numbers, or could also be numbers and words, etc. So let's have here S plus, so one or more space, and then we have a digit, one or more digit, and then we have W star, and this to check if we have a word after a certain number of digits. For example, here, let's see here, 710. After it, we have F, and F could be here treated as one character or a word. Also, we have here ultra could be treated as a word after these two numbers, or spaces, one or more space, and simply W plus. And this to check all of the words after one or more spaces. We will change all of these into empty string, regex equals to true. Let's print again the unique values. We have now only the names of these processors. To handle the rest of these values, I made the code. So we have here mask now. This variable contains multiple masks. First, we have this Samsung, then the no string. Also this number 4, which is treated here as string, of course. Also, we have this regex. This means that match this bracket and then 0 or 1 digits inside, and then match this closing bracket. And this is for this 6 and 4. And also match this string octa or quad string, also using regex. I passed these masks using the OR operator to the locate method. Then we have this Snapdragon. I used a mask for it and then changed it to Snapdragon. We have right now here in Google Tensor, and the rest is all non-values. The next step is filling the missing values for this categorical columns using the mode function. This function will return the most often value in a column. So let's have here 4 columns in our categorical columns. We will cast all of these to lowercase values. This will remove all of the trailing spaces, and then we'll change all the values into lowercase ones. Using the fill na method, we will use the mode of this column, 0 in place equals to true. For the company column, we have the unique Samsung, Vivo, etc. For the processor, Octa, Quad 9, and Deca. For the processor name, we have these values, and all of them are lowercase. The last step here is to OneHot encode our categorical data. OneHot will not have a certain order, so all of our data will have the same importance. Let's have here dataset OneHot, and we will use simply the pandas get dummies method. We will pass our dataset and our columns that we want to change. This method will create for each value a certain column, and inside this column we will have 1 for the presence of this value and 0 for the missing of this value. And we could check that for each value we have a column. And let's, for example, print this dataset OneHot at column processor name Snapdragon. As we could see, we have first true, 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 and then false, false. This means for the 3 first records, this Snapdragon value is present, and then for this 4th and 5th record, this Snapdragon value is not present. To check if this is true, let's simply print from our original dataset the processor name column again and 5. And we could see that for the first 3 records, we have Snapdragon, 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 and this is why this true value is here present. And then for the 4th and 5th record, we have Helio, and this is the reason why we have here false. As I said before, I will pre-process the numerical data in later video. Just to make this one short, I highly encourage you to check for this get dummies method, also for how OneHot encoding works, and for this mode method. And that's it. See you in the next video.